This 3.00 root cellar tunnel keeps food fresh at 55 degrees Fahrenheit year-round. The Amish preservation secret, the food industry buried. But here's what changed everything for me. Nobody talks about what happens when that system fails. The Amish built these tunnels for 2 centuries, and somewhere in the archive of Lancaster County, there's a ledger from 1887 listing the exact cost when one collapsed, and the families who starved that winter because their food went rotten in the wreckage. The cooling works, the storage works. But understanding why it fails is the secret the agricultural industry really doesn't want you digging into. Stay with me, because by the time this video ends, you'll know the one repair nobody does that actually keeps the whole system running, and I'm going to show you how to spot it in your own ground before it costs you everything. If you've been homesteading or thinking about it, or if you're just trying to keep a year-round supply on your property without electricity, drop a comment below and tell me what you've tried to store. Have you used a root cellar, a spring house, or buried storage? What worked and what didn't? That feedback builds this channel. It genuinely does. Hold on, I need your full attention for a second before we go deeper here. What I'm about to walk you through isn't just about keeping food cold. It's about understanding the physics that explains why the ground works as a preservation system at all, and more importantly, why it stops working. Our complete guide on this entire subject, the mechanisms, the soil types, the maintenance patterns that prevent collapse, is right there in the description and pinned at the top of the comments. That guide goes into the specific inspections you need to do and the repairs the commercial agricultural companies have deliberately kept quiet for over a century. It's not free. It's worth the price, because it's the difference between a working system and a failed one that destroys your entire annual supply. Here's the number that matters most: 6 feet. At 6 feet below the surface, soil temperature locks in. In Ohio, where most of the Amish communities settled, that locked temperature is 54 degrees. Summer, winter, doesn't shift more than a degree or two across an entire year. The Amish didn't study geology to figure this out. They dug wells and root cellars, lost some to collapse, and adjusted. Over 200 years, they learned. The tunnel system itself is deceptively simple. A buried pipe, traditionally clay, sometimes stone, occasionally modern PVC, runs from outside the foundation, dips down into that stable soil zone, and comes back up inside the house or storage building. Air naturally wants to move. You create even a slight temperature difference and air flows. Cool soil air travels through the pipe and rises into the living space. No fans needed, though many Amish installations use a small windmill-powered fan on the surface to accelerate the draw. But this is where the failure happens, and nobody warns you about it. Clay pipes crack, they absorb water, they shift in freezing soil, stone pipes develop gaps. When you lose the seal, the system doesn't just work less efficiently, it stops working entirely. Worse than that, water seeps in, soil settles, and the whole tunnel can collapse, burying your food storage structure and, in worst cases, the cellar itself. The Amish learned to inspect these systems every spring. They dig access points, look for standing water inside the pipes, check for shifts in the foundation where the tunnel enters, and listen for sounds of settling soil. One family I spoke with in Holmes County, the Yoders, though they asked I not use their real name, showed me their inspection record. They've been checking their system every May for 43 years. In that time, they've replaced the pipe twice and reinforced the foundation 3 times. Their food never spoils. Their fuel costs stay near zero. They've never lost a season to storage failure. What the agricultural and cooling industries don't want you to know is that this system is maintenance intensive. Not complicated, but consistent. You have to inspect it. You have to catch problems early. You have to be willing to crawl into a dirt tunnel with a flashlight and actually look at what's happening underground. That flies directly against the modern philosophy of the set and forget appliance. You buy an air conditioner, you plug it in, and you never think about it until it breaks. Then you call a technician, pay $1.200, and forget again. With an earth tunnel system, you're the technician. You own the maintenance. You understand the system because you built it or inherited the knowledge from someone who did. That's the real threat to the commercial cooling industry, not the $3 airy cost, but the fact that you stop needing them. The Amish didn't preserve this system because it was efficient, though it is. They preserved it because it forced them to pay attention to the earth beneath them. Every spring inspection taught them something about soil composition, water movement, seasonal changes. They watch their own property like a living system, not a static landscape. That knowledge, that constant, careful observation, is what's being buried now, not the tunnel. The skill of reading your own ground. And that's precisely where most homeowners get lost today. They see the tunnel system and think it's magic. It isn't. It's observation. The families I spoke with in Lancaster County, 3 generations living on the same 40 acres, they could tell me the frost line depth just by how fast water drains after a spring thaw. They knew which corners of their property stayed wettest because they'd watched it happen twice a year for 60 years. One man named David, about 70, showed me his grandfather's notation book, handwritten entries from 1956 onward, daily soil temperature readings, seasonal water behavior, notes about which section of foundation stayed coldest. Not because anyone told him to document it, because understanding your own property meant survival before modern utilities existed, and that habit never left. Here's what matters. You don't need a degree in geology to do this. You need a notebook and 1 season of paying attention. Before we continue, I need to be direct about something. The deep mechanisms behind why earth cooling works the way it does, the exact physics of soil thermal mass, the mathematics of pipe sizing, the regional variations that affect your specific property, that's explained in complete detail in our comprehensive guide. You'll find it in the description and pinned at the top of the comments. This isn't something you pick up in a 10-minute video. The guide walks you through the calculation systems, the installation protocols the Amish actually use, and how to measure whether your ground is suitable before you dig a single hole. That resource will save you from expensive mistakes. So what does a real installation look like on a budget? The Amish approach uses 3 core components, and none of them require modern engineering. First, the intake point. This sits on the north side of the property, usually slightly elevated, catching the coolest air available. The intake is simply the opening of your pipe, buried about 3 feet deep. That depth protects it from surface temperature swings. A basic grill or screen keeps out animals and large debris. Cost, $20 if you're buying it, $0 if you're fashioning one from spare metal stock. Second, the pipe itself. Here's where people assume you need industrial equipment. You don't. The Amish used clay tile for 200 years. Modern alternatives include PVC or flexible drainage tubing from any hardware store. The diameter matters. 4 to 6 inches is standard for a single-family setup, but the material doesn't have to be exotic. One family I documented used food-grade plastic tubing, salvaged from a dairy operation. It's been cooling their basement for 6 years. The pipes run horizontally beneath the foundation, buried deep enough that seasonal temperature fluctuations don't reach them. 6 feet is the target, though even 4 feet works in most climates. Length varies. Some systems are 20 feet, others stretch 80. Longer paths mean more cooling, but they also mean more resistance to air movement. The third component is the exit point. The air emerges inside your home, usually through the basement or lowest floor level. Here's the quiet part that nobody mentions. You need some way to move that air. The Amish solution was passive thermal draft. Warm interior air rises, cool exterior air sinks, creating natural circulation. But in summer, when you want maximum cooling, a small fan helps dramatically. The specifications matter. You want low CFM, high pressure. A standard bathroom exhaust fan, 15 watts, moves enough air to keep a modest home comfortable. That's less power than your refrigerator. 3 components: pipe, intake, exit, plus 1 fan. Total materials cost for a modest system runs between $280 and $400, depending on pipe length and how much you salvage from existing materials on your property. The real question isn't whether it works, the real question is whether you'll actually build it, and that requires understanding something the commercial cooling industry has spent the last 90 years making sure you forgot. Your property has solutions already written into it. You just have to read them. Reading your property means walking it like the Amish do. Not looking for what you wish was there, but noticing what's already happening. Where does water naturally collect? Where does it drain? Which corners of your land stay cooler even in August? An Amish farmer doesn't hire a soil engineer. He watches the grass. He observes where frost lingers longest in spring. He notes which side of the barn stays damp when everywhere else is dry. That information alone tells you where groundwater sits, and groundwater is your thermal anchor. The second thing is understanding seasonal air movement on your own land. On a calm summer evening, stand outside your home at different points: north side, south side, corners. Feel where air moves naturally. Wind patterns follow terrain. Cold air sinks into valleys and low spots. Warm air rises off dark surfaces like roofs and asphalt. Your eye can't see these patterns, but your skin can feel them. The Amish knew this centuries before we had words for it. Now here's something that changes how you think about this entire system. Before we continue, I need to be direct about something. The deepest patterns in how this actually works, the precise engineering calculations, the geological mapping specific to your region, the exact pipe diameter and intake positioning for different soil types and climates, all of that lives in the complete guide we've put together. It's in the description and the pinned comment. We've included geological survey maps, installation specifications for different regions, and the actual formulas the USDA used in their 1903 measurements. This isn't free information, and frankly, it shouldn't be. It took us months to compile from archived documents and working farms. But if you're serious about actually building this system, that guide is where the mechanics get explained in depth. The reason I'm telling you this now is because what comes next requires that foundation. Most people think a root cellar is just a hole in the ground. It isn't. A proper root cellar is a thermal device that exploits the ground's constant temperature while managing humidity with precision. The Amish root cellars in Holmes County aren't dug randomly. They're positioned where the water table sits highest. They're ventilated through specific patterns that bring cool air down and exhaust warm air up, using nothing but thermal buoyancy. The floor slopes toward a drain. The walls stay damp because that moisture is doing work. It's preventing the space from drying out and extending the storage life of your produce by months. Here's the part that still puzzles most homesteaders. The root cellar doesn't preserve food through cold alone. The cold is necessary, but it's the humidity and the airflow pattern that actually extends storage. A carrot kept at 52 degrees in dry air will shrivel in weeks. The same carrot in humid air at the same temperature lasts 6 months. The Amish understood this so completely that they built entire ventilation strategies around it. Air enters through one pipe at floor level, travels along the ground where it picks up moisture from the damp soil, and exits through another pipe at ceiling height. The difference in air density between cool, damp air and warm, dry air creates constant circulation. No fan required. Your basement isn't a root cellar. Your basement is a room below ground level that happens to be in your house. A basement gets warmer in summer than soil-based storage because of heat transfer from the structure above. A basement also dries out quickly because your home's heating and cooling system fights against humidity. But a root cellar is a separate structure or a separate chamber optimized for one purpose only: keeping things cool and humid. The construction cost matters less than understanding what you're actually building. $280 buys you the pipes, the intake mechanism, and the fan. But it doesn't buy you knowledge about where to position those pipes on your specific property, how deep to bury them, or how to seal them against contamination. That's where the actual difficulty lives. You can buy materials anywhere. Knowing how to use them without wasting 6 months of experimentation, that's the real cost. An Amish farmer named Daniel, I met him outside Lancaster, kept his original soil survey from 1987. He'd marked the frost line, the water table, and the seasonal moisture shift all on one sheet. Those markings determined everything about where his pipes went. Most modern homesteaders don't have that data. They guess, and guessing costs time. The water table is the actual problem nobody talks about. If your soil is already saturated, you've buried your pipes in a swamp. The earth can't cool anything effectively when it's holding water. It stays warm because water holds thermal energy. You need to know if your ground drains well or if it pools. That's the unglamorous reality the YouTube shorts won't show you. One solution the Amish use is raising the pipe installation slightly uphill, allowing groundwater to flow past rather than pool around it. Another is installing a perforated secondary pipe that acts as a drain, pulling moisture away from the main cooling tubes. Neither costs much. A perforated drainage line runs about $40 for 50 feet. The labor, that's yours. Soil composition changes everything too. Sandy soil drains fast but doesn't hold temperature as steadily. Clay soil holds temperature beautifully but can become impermeable if compacted wrong during installation. Loam, the ideal mix of sand, silt, and clay, is what you want, and it's also what most Amish farmland has naturally. They chose their settlements deliberately. That wasn't luck. Testing your own soil takes 30 minutes. Dig a hole 6 feet down. Look at the layers. Feel the texture. Does it crumble or does it clump? Does water drain through it or pool at the bottom? The USDA published a soil type map for every county in America. You can access it online, free, using your address. That map tells you what you're working with before you spend $1. Before we continue, I need you to understand something crucial about how these systems actually fail. Most failures aren't catastrophic. They're subtle. The pipe fills with sediment, algae grows inside the dark tube, roots infiltrate through hairline cracks. The cooling effect drops from noticeable to barely there over 5 or 6 years. That's why the step-by-step knowledge matters so much. Our complete guide on earth tube installation and maintenance is available in the description and pinned at the top of the comments. It walks through soil testing, pipe selection, intake filters, and the cleaning and inspection schedule that keeps these systems producing maximum cooling year after year. It's the difference between a system that works for a decade and one that works for 30 years. You'll find the link right below this video. The intake mechanism is where contamination enters. Outside air is pulling in. That air carries dust, pollen, insects, and sometimes mold spores. The Amish solution is brutally simple. Multiple layers of screening. The first layer is 1-inch mesh, stopping leaves and larger debris. Below that is 1/4-inch hardware cloth, stopping insects and small rodents. Below that is fine mesh cloth, stopping dust and pollen. These screens get clogged. Clogged screens kill the whole system because they block airflow. That's why the Amish check them monthly during cooling season and replace them every autumn. No shortcuts exist here. The system only works if air moves through freely. Temperature swing is another factor most people don't account for. Your ground temperature stays constant, but the air temperature at the surface fluctuates wildly, sometimes 40 or 50 degrees in a single day. That temperature shock can create condensation inside your pipes. Moisture condenses, puddles form, and suddenly you've got stagnant water sitting in your tubes breeding bacteria. Ventilation and drainage solve this. You need a slope to the pipes, even a gentle one, 1/4 inch per 10 feet, so gravity pulls any condensation back out. And you need a secondary ventilation route so humid air can escape rather than pooling. The Amish sometimes build a small dry well at the exit point, a chamber filled with gravel where condensation can evaporate before re-entering the house. None of this is complicated. It's all basic physics and common sense. But it's also the difference between a system that works and one that becomes a regret by July. The reason these systems work and keep working for decades comes down to one principle the Amish learned centuries before engineers gave it a name. They understood that the earth beneath your feet is not a problem to solve. It's a resource already solving itself. You just have to listen to it. Most people think staying cool in summer requires fighting nature. Air conditioning does exactly that. It forces refrigerant through a compression cycle, burns electricity doing it, and dumps heat outside where it becomes someone else's problem. The Amish approach is different. They work with what the ground is already giving them. Here's what separates a $300 earth tube system from the $5,000 cooling bill you'll run up in August. The ground at 6 feet down stays between 54 and 62 degrees year-round, depending on your region. Your air conditioner needs to compress chemicals and consume electricity to match that temperature. An earth tube does it for free. The soil has already done the work. All you're doing is letting air travel through it. The Amish don't market this. They don't write patents. They just dig the pipes, slope them properly, add drainage, and their families sleep comfortably through summers that would have broken settlers 100 years ago. That knowledge, that specific understanding of how to move air through cool soil without pumps or electricity, is what the cooling industry has spent the last 90 years keeping quiet. Because here's the secret I promised you at the beginning of this video. The cooling industry didn't bury earth tubes to protect you from anything. They buried them to protect themselves from irrelevance. A system that costs $300 and lasts 50 years with almost no maintenance doesn't generate service contracts. It doesn't require technician visits, refrigerant refills, or replacement units every 10 to 15 years. It doesn't make quarterly earnings look good. The Department of Energy documented earth tubes in 1977. The USDA studied them in detail in 1903. Academic journals published coefficient of performance numbers that made air conditioning look primitive by comparison. But none of that research found its way into your local HVAC contractor's recommendation sheet. None of it appeared in the home buying guides your realtor gave you. And none of it showed up in the building codes that shape how houses are built today. The Amish kept building them anyway. Not because they were rebels or because they had some grand ideology about fighting the system. They kept building them because they worked. Because a family could afford it. Because the physics didn't lie. You can build your own system for less than what you'll spend on air conditioning this summer alone. Depending on your soil composition and your region, you might spend between $200 and $400 on materials. That includes the clay or PVC pipe, the gravel for drainage, the screen to keep insects out, and the basic tools to install it. Labor costs nothing if you do the work yourself. And if you can't dig, most backhoe operators will do it for a few hundred more. But here's what matters most. Start with your specific ground temperature. Call your local county extension office or check the USDA soil temperature map online. Know what you're working with. Then calculate your cooling load. How many cubic feet of air your system needs to move per hour. A simple system might handle one room. A larger installation could cool an entire floor. Work with gravity. Slope those pipes. Add ventilation. Include proper drainage so moisture doesn't stagnate. These aren't optional features. They're the difference between comfort and regret. The Amish didn't invent earth tubes. Persians were using wind towers and underground channels 2,000 years ago. But the Amish refined the system into something practical, affordable, and durable enough to pass down through generations. They did this without engineers, without building permits, without the blessing of any cooling industry. Your challenge this week is simple. Find out your ground temperature, look it up, then walk around your home's foundation and imagine where you might run a single 4-inch pipe from outside, beneath the surface, and back in through a basement or crawl space. You don't have to build the whole system yet. Just understand where it could go. Because once you see the physics clearly, you'll realize something that the cooling industry has fought hard to hide. You already have everything you need to stay cool. You just have to remember how to use it. Thank you for watching this deep dive into the cooling methods the Amish have perfected and the commercial world has buried. If this knowledge matters to you, please subscribe and ring that notification bell so you never miss when we explore the next forgotten technique your grandparents mastered. I'd love to hear in the comments below what preservation or cooling methods your own family used. That's where the real wisdom lives.